Welcome to Module B, Lecture 1. In this module, we shall discuss about the overview of 4-stage urban transportation planning process. In urban transportation planning, the most important aspect is travel demand forecasting. We try to predict the travel demand that is expected to be served by the transportation system in the future, and then we also in that manner try to predict the impacts of various policies and program on the travel demand in urban areas. You change the policy, you change the program, then how that is going to or how those are going to impact the travel demand in an urban area or in various contexts. In an urban area, the demand for transportation is created by the separation of urban activities. Urban activities are the key. All travel generates, all travel happen because of these urban activities. So, the demand is created by the spatial separation of urban activities, activities located in different places. You live in one area, your office is in another area, a school is located somewhere else, the shopping mall is located in another place. So, that is the spatial distribution of activities which create the transport demand. The supply of transport demand is represented by the service characteristics of the transportation network, because you have set of roads in any given network. So, each road has a capacity. So, overall road corridor or network or the transportation system is there. So, that capacity is offered to accommodate the demand for transport. Now, the forecasting whatever we get from the overall transport planning process is, as I said, the travel demand forecast is the key. Then this travel demand forecast provide detailed information for various work. Say for example, we can understand that how much traffic volume will come on a particular link, and thereby we can compare that whether the link capacity or the number of lanes which are there in that link, whether that number of lanes is adequate to serve the demand with the expected level of service. Similarly, one can get the bus patronage to understand you did some policies and program. So, what is the impact of that on bus patronage? It may increase, it may decrease. So, that is again the use of the transport demand. We can also understand probably say how much turning volumes or intersection volumes one intersection has to handle. And if we can predict that in future so much traffic volume is to be handled by this intersection, then we can easily try to estimate or assess rather that whether that intersection will require signalization or not. If we do the signalization, what kind of signalization will be necessary, then with signalization what kind of delay will occur in that intersection. All such kind of things can be worked out. Then coming to this 4th stage, we are saying that we are going to discuss here about the 4th stage planning process. So, the 4 stages are or steps are: first, what is called as trip generation. Here we try to forecast the number of trips that will be made given the land use, given the activities in the whole study area of course, but then in small pockets within the study area. So, study area is divided into smaller zone, because every time we are saying the transport demand is spatial in nature. So, not the whole demand from the study area, but in smaller pockets, smaller geographical regions, how the demand will happen. So, that number of trips that we try to forecast or assess in the trip generation stage. Then in next stage or step, what is called as trip distribution, we try to get the answer that if 100 or 1000 trips are getting generated in one area, where these trips are going, because every trip which is generated must be going somewhere, you know. So, there is a destination for the trip. So, how the trips are getting distributed? Similarly, if I know that in one zone so many trips are getting attracted, then we would like to know in this stage, in trip distribution stage, where from those trips are coming. So, if it is a generation that thousands or hundreds are getting generated, then how they are getting distributed to different zones, where they are going. And if I consider the other end, that okay, 1000 or 100 trips are getting attracted to a zone, then we also know from this stage or in this step that where from this 100 or 1000 trips are coming. So, we know completely the origin destination of the trip, right. Then in step 3 or stage 3, whatever you say, which is called the mode choice, we try to predict how the trips will be divided among the available modes of transport. Till this step 1 and step 2, you are talking about passenger trips, but then the roads are actually getting loaded with vehicles. So, in between what is happening? The passenger trips are getting converted into vehicle trips. So, that is happening in this stage, what we call as mode choice. Say 1000 people will travel from point A to point B, for example. How? Each of them is traveling using a car, that would mean that there will be 1000 cars between 2 points traveling at a given time. If they are all going by bus, then I know if it is a 50-seater bus, then that will mean probably 20 buses that will get required. So, understand that this mode choice is extremely important in the context of overall urban transportation planning process, and especially the mode choice part is so important. That is why in the overall urban transportation planning process, because the number of vehicle volumes or the number of vehicles or the overall vehicle volume is decided or influenced heavily by the mode choice decision. So, lot of works are being carried out even till date on this mode choice modeling, to see how we influence the mode choice decision of individual. And then significantly, even though you are carrying same number of people from one point to another point, the number of vehicles can be very different, and if the number of vehicles can be different, then the loading also on the road network may be very different. The resulting emission, the resulting congestion will also be entirely different, indicate entirely different scenario. So, this is very important step. The last and step 4 or stage 4 is the traffic assignment. So, we know where people and how many people are trying to travel, where they are going, or if there are some people coming here, then where from they are coming. We also know by which mode they are coming. But in a transportation network, normally there are multiple paths available. If you want to travel in bigger cities, if you consider somebody is trying to travel from point A to point B, there are multiple options for travel, right. So, here how this demand is getting distributed to different routes. Obviously, personalized mode, if you are traveling in a private vehicle, you have much more choice, right. Any route if you wish you can take. Buses, they follow the fixed route, because normally bus routes follow certain sequence of links or certain predetermined path. So, but whatever it is, this is the step where we know how the demand by a given mode from a point to another destination point, how the demand is getting distributed to different routes, or how the route choice decision is happening. This is again very important, because we said earlier, and you already know, that transport demand is temporal and spatial in nature. So, even in a transportation network, not all roads are equally loaded with traffic at a given time. Maybe some routes are highly congested, and whereas some other routes it may not be really that congested, right. So, this is very important to see how the route choice or the traffic assignment decision is made by individual and what it means in collective sense. So, these are the 4 stages: trip generation, trip distribution, then mode choice, then traffic assignment. And we are assuming here that these decisions are made in a sequential manner. In reality, some cases it may be a combined decision. You want to go to a destination. When you are thinking of the destination, you are also maybe thinking about the choice of mode or how which mode you will take to travel. But generally, we in this 4 stage planning, we consider that the decisions are made in a sequential manner. Then in this flow chart, I am trying to show an outline of the 4 stage planning process. As I said that everything starts with urban activity, that is the center, because the activities are distributed. So, people need to travel, otherwise there is probably even no need to even travel in an urban area, right. So, if everything, of course, you can still travel for recreational and social reason, but suppose if your office is located in the same building hypothetically, and if for whatever you want, your all shops, bank, anything you want is located in the same building, probably you do not need to travel outside your building, right. So, you need to travel predominantly because the activities are spatially distributed. So, the key input to this 4 stage planning process is the distribution of urban activities, how the activities are distributed. So, the urban activities provides input to this trip generation process, and then the trip distribution, then the mode choice decision, and then you can see here this whatever I said as assignment. Here actually I am showing it as 2 different boxes. One is highway assignment, the other is called as transit assignment. Now, why these 2 boxes? Because the principle followed for assigning traffic is different for private vehicle and the public transport mode. As I said, public transport modes, in most cases public transport follow fixed route system. So, the routes are predefined. Bus route will not change suddenly based on the traffic state. Extreme situation it can change, right. There is an accident, probably the road is blocked. So, the bus can take a different route, but otherwise not so. So, in general the assignment philosophy is very different. That is what is called the transit assignment, and highway assignment is basically is actually refers to the assignment of private vehicle. Now, you can see here highway and transit network, it provides input to both trip distribution and to mode choice or mode usage. Why? Because both trip distribution and mode choice decision depends on the highway and transport networks, that what are the characteristics of the transportation system, that becomes very, very important. Because where you want to go, I mean given 2 equally attractive destination to equally same shopping mall in 2 different locations. One is very well connected by transport network, and the bus system is very well developed, connecting those 2 points with frequent service and so, and the other location shopping wise it is equally the same shopping mall, probably you can consider, but the transport connectivity is not so good. So, where people will go more? People obviously will go more where the transport connection is better. So, the transport and highway and transit network, they influence the transportation distribution or the trip distribution. Same way, what modes one will choose for travel between point A to point B also will depend on the characteristics of the highway and transport network. So, obviously, if there are a very good bus system, maybe more people would travel by bus, and therefore, you will find the mode choice will show higher share in favor of public transport, right. Now, this feedback arrows again after highway assignment going back to highway and transit network. What is the reason for that? That reason may be explained as follows. When we are doing trip distribution, we are assuming some value of travel time on certain properties of the or the characteristics of the highway and transit network. Same thing, we are assuming certain characteristics of the highway and transit network when we are going the mode choice, right. But how much actually will come on a given link or on a given route and on a given intersection at a given intersection location and so on so forth will be known once the actual distribution and the mode choice and the route assignments are done. So, whatever assumptions on travel time and network characteristics or properties we assumed, we need to recheck. Maybe we assume that to travel between 2 points it will take 15 minutes, but after the loading of the network, does it really take 15 minutes? It may take even 20 minutes, 25 minutes, it may take little bit lesser as well, right. So, we need to go back and again with the revised one, we need to update the network and the travel time, travel cost and every other parameter accordingly, and maybe we need to go back to trip distribution or mode choice as the case may be, and then repeat the procedure till the whole process is really stabilized. So, if I have to summarize this flow chart, we would say that as I said, urban activity forecasts provide information on the location and intensity of future activity in an urban area and provide primary input to the trip generation process. Everything starts, travel demand forecasting starts, the basic input is urban activity forecasts, right. So, the description of highway and transit network, it provides information necessary to define the supply of the transportation in that area. What is the supply of transportation? As I said earlier, the supply relates to the transport network, right. And so, it defines the supply, it defines the characteristics that are important for the 4-stage planning process, particularly the choice of destination, the choice of mode, the choice of route, right. And then the 4 phases which shows actually the try to predict the travel demand, and the feedback arrows as you said that the arrow is coming back here, right. So, this feedback arrow they represent checks on the earlier assumption made on travel time and determine if adjustments are necessary. As I said that we assumed certain characteristics of the transportation network and accordingly assumed some travel time, travel cost, and based on those network characteristics or travel time, travel cost, we did distribution, we did mode choice, we need traffic assignment also after that. So, the actual now the loading is known. So, you can check whether the travel time assumptions or travel cost assumptions what were made earlier, whether they are still valid or whether they need some kind of update, right. So, that is what is the process. Now, going to each stage little bit. Urban activity forecast provide estimates of where people are expected to live and where business will locate in the future, because we are going for forecasting. Forecasting means future. So, we need to know the future land use and in particular the future activities, how the distributions will happen. Maybe the development authority has certain plan that certain areas they want to develop as the residential areas, right. Maybe lot of housing projects are coming up. Similarly, maybe the government has decided to develop some areas as the IT park, right, that this area will be developed as a big IT park, right. So, we need to know and this activity forecast help us to know how the activities will get located. So, where people are expected to live, how many people are expected to live, where the businesses are expected to be located. So, it includes intensity of activity, that means in number, how many number of household or how many number of business, right. And these numbers are available not for the whole study area at a gross level, but also for smaller pockets or what we call it as traffic zones. So, in smaller zones, each traffic zone in the study area, how many people are expected to live, what kind of business or employment opportunities are expected to be located. These are all available through urban activity forecast and they provide the input. Those are the real inputs which are used for trip generation process. Now, zonal activity forecasts are primarily based on three major considerations. I would say one is the total urban area population and employment estimates, because first you are talking about the study area. In the whole total urban area, what is the total population and employment that are expected to be there. Then how they will get distributed or in different areas, that depends on obviously one way the location behavior of people and business, where what kind of policies are there, where which are likely to be more preferred destination for locating a business house or a particular type of industry, or where people would naturally prefer to live end of the day as residence locations, right. So, locational behavior is of people and business are important, and also the local policies regarding land development, transportation, zoning and all other kinds of urban infrastructure, right. So, how the government are trying to promote the policy. I mean, it also depends, because maybe the western and eastern suburb both can develop, but government can take policies to promote development of certain area in certain direction, right. Because you may land policy and development policy, the kind of the government policies can come in a big way to encourage or to promote development of certain areas. So, it depends on then three major areas: what is the total urban area population and employment estimate, what are the location behavior of people and business, and what are the local policies regarding land development, transportation, zoning, etc. Now, activity forecast, as I said, are very important, because they are the inputs to the trip generation or the 4-stage transport planning process. So, activity forecasts are direct inputs to the next stage of the process, that is called trip generation analysis. Now, in trip generation analysis, what we are doing? We are taking the activities as an input and we are trying to predict, then that will mean what level of trip generation, how much trip generation. So, we can say in trip generation is the process by which measures of urban activities are translated into number of trips, because we are taking input as urban activities distribution, and the output what we are getting from trip generation is basically the number of trips, right, in each zone. So, the nature of activity is very important consideration, nature and quantity, right. So, both are important. Why the number is important? We said that how many people, how many buildings or houses are expected to come, or how many industries are expected to be located, but that is the number is important. But along with the number, the nature of activity is also equally important. Why? Because I say that, let us say for example, as given here, the number of trips that are generated by a shopping center is quite different from the number of trips generated by an industrial complex. So, even if you consider say industry, even within industry, a manufacturing industry and IT industry for example, right. These two types of industry, for the same area of the industry, the number of people who are likely to be employed will be entirely different. So, the nature of activities is also very important. So, in trip generation, the planner attempts to quantify actually what is the relation between urban activity and travel. So, because why I am saying the relationship? Because my input to the trip generation process is urban activity forecasts, right. What I am getting as output is the trip generation, number of trips. So, that means somewhere the number of activities are getting translated to number of trips. So, we are basically developing the relationship. If this is the type of activity, then this is going to be by number of trips. So, I can say that the planner attempts to quantify the relationship between the urban activity and the travel. Then the output of the trip generation is a table of trip ends. That means, if I consider it like a matrix, if I have n number of zones in a study area, then each cell within that matrix will represent what? Trip from I to j, right. So, if I add all the cells in a row, that will say 1 to 1, 1 to 2, 1 to 3, 1 to 4, 1 to 5, like that up to 1 to n, that the total is how much? How much is getting produced in 1. Similarly, if you take a column and try to add all the cells in a column, it should be maybe 1 to I, 1 to j, 2 to j, 3 to j, 4 to j, like that n to j. So, you add all this, that means how much are coming to zone j, right. So, by trip generation, we estimate these row totals and the column totals. So, basically I do not know the inner cells, but I know the row total for every row and the column total for every column. So, if I have n number of zones, then the row total gives how much each of this zone is likely to produce and how much each of this zone is likely to attract. Those are the column totals. So, that is what I said, that output of the trip generation is a table of trip ends, the number of trips that are produced and number of trips that are attracted by each zone. The purpose of the trip also could be, we can classify trip by purpose, and the analysis is critical out, because it is the first stage. And what kind of method we use? We use multiple linear regression or cross classification techniques. We shall discuss about these techniques in details in our next stage, next module, when we go for the trip generation analysis. The next is the trip distribution. What I said, if I simply refer to this matrix what I was referring to, that we know the row total and the column total, but we do not know what are the inner cells. So, the trip distribution is the process where we are trying to identify what are the individual cell values, right. So, that if you add each zone all the cells in a row, you get the row total what you have estimated from the trip generation, and if you add all the cells in a column, that cells sum should give you the column total, which is the attraction you have estimated from the trip generation. So, trip generation gives me row total and the column totals, but not the individual cell. Distribution gives us the individual cells. I can say also in other words that if I am saying that trip generation will tell me 1000 trips are getting produced from one area, but it does not tell me how the 1000 trips are going to different zone, how many are going to zone 1, how many are going to zone 2, and so on and so forth. Similarly, trip generation may tell me the 1000 trips are getting attracted to a zone, but I do not know where from they are all coming. How many are coming from zone 1, how many coming from zone 2. So, those information are given in the trip distribution. So, that is what I have written here, that where do the attractions in a zone come from or where do the productions go. What are the zone to zone travel volumes, that is the individual cells which are not known in the based on trip generation, and that is what we get in the trip distribution say. The output of the trip distribution is a set of tables that show the travel flow between each pair of zones, or you get each individual cell in that matrix. So, by the end of trip distribution, as you know that in generation stage probably we only found out that example here 1633 trips are expected to get produced in zone 1, but how they are or where they are going, that we are not knowing. But once we have done the distribution, we know that out of 1633, maybe 333 trips are going to terminate in zone 1 itself, because there may be some attraction points within that zone itself where they will get terminated. Similarly, 600 trips probably will go to zone 2, 200 will go to zone 3, 300 will go to zone 4, and 200 are going to 200 trips are expected to go to zone 5. So, like that we know how they are getting distributed, right. So, the decision on where to go is represented by comparing the relative attractiveness and activity of all the zones, and mainly two types of approaches we take for modeling of trip distribution. One is called the growth factor based models, and we also use synthetic models for getting the trip distribution. As usual, as I said, like the trip generation models. So, here also the trip distribution models in details we will discuss when we go to the module D, right. A, B, C is trip generation, D is the trip distribution. So, when we go to module D, we shall discuss in details about this growth factor based model and the synthetic models. Third, as I say, by which mode they will go. So, here we are analyzing decisions regarding mode of travel, whether how many trips are going to be made by auto. Auto means here the car or the personalized vehicle, how many are going to use bus or train or taxi, and so on and so forth. So, mode choice analysis is normally carried out after trip generation, but also can be done at various points in the forecasting process. As I said, sometimes even it may be taken simultaneously the decision, but here we are considering for simplicity that the decisions are made in sequence: generated, then the destination, then the mode, and then the what route to take, right. So, broad categories of factors which may influence the mode choice decision may include characteristics of the trip maker, how much income I have, okay, high income, low income, male, female, even a young person and an old person. So, the socioeconomic characteristics and the characteristics of trip maker are very important. They may influence the mode choice decision. Characteristics of the trip also may influence the mode choice decision. So, for example, somebody is going to the office, maybe the travel time is the most important factor, right. So, he or she will probably take a mode where the travel can be faster, right. But the same person in the weekend when going or out along with the family to a restaurant or for a social trip, okay, may prefer to travel in a more comfortable manner. So, the comfort may get much higher priority, right, and accordingly the mode choice decision will happen. Similarly, the characteristics of the transportation system, what are the available, how the bus service is available, whether the taxis are or autos, shared modes are available, all these, what is the travel cost, how much time it takes, all these are also going to influence the choice decision. So, the characteristics of trip makers, characteristics of trip, and also the characteristics of the transportation system, all are going to influence the mode choice decision. So, when the mode choice decision has been done, then we know not only that how many are going to a particular zone, but we also know, say for example, 200 people are going to zone 3, but we know after mode choice analysis, out of 200, 150 will go by car and 50 will go by bus, such kind of information. So, the person trips are actually getting translated into vehicular trips. Okay. So, when the relationship have been captured, that how the choice decision made, the planner can predict how the population in future will choose among the available modes that are likely to be available. The last is basically the traffic assignment. As I said, this tells you how or the path or the route choice decision will be made. So, destination decision, then the mode choice decision, and now the route or the path choice decision, which route or which path to be taken. So, it is the process by which planners predicts the path the trips will take. The assignment process begins with conducting a map representing the transportation network in the study area, you need to know how the transportation network is there, what are the characteristics, how much is the travel time, what are the possible paths the trip can take, and so on and so forth. That means the intersection, how many intersections will come on this path, what are the links, what are the travel time along the links, all such things are. So, the network properties become very, very important. Several information regarding the link are recorded. For example, the link, the type of the facility, the location of the area, number of length, what is the speed or the travel time, all such thing. If transit is available, then what is the fare, what path it takes, how much time it will take, all this will govern the choice decision about the route or the path. And the output of the traffic assignment analysis show the paths that the trip will take, and therefore, the number of vehicles each roadway and the number of passengers on each transit routes. So, finally, end of the traffic assignment, the actual load for a given link or for a bus route and for a given intersection, all these are available. So, that is what are the 4 stages. So, what we discussed here quickly is the overview of the traditional travel demand forecasting process. As I say, the inputs are coming from the urban activity forecast. So, they are providing input to the 4 stages, and 4 stages are namely the trip generation, activities to number of trips, distribution telling me the interchange, where from the trips are coming or where the trips are going, which are generated, right. Then the mode choice decision tell me how the trips are getting distributed to available modes, and the traffic assign tell me that how the trips from one point to another point using a particular mode, how they are getting distributed to different routes or different paths to give me the final demand in terms of link volume, intersection volume, bus ridership, and so on and so forth. Thank you so much.